Jai Hind. I am Madhup Agrawal, Assistant Professor in IT Department from AKGEC Engineering College, Ghaziabad. Our today topic is graph traversal. So, graph traversal techniques used to traverse the graph. Before that, we review what is graph. As we know, graph is a non-linear data structure. Graph is a non-linear data, not in the linear fashion. Means just as we know, list is a data collection in linear fashion, means one after another, but in graph there is non-linear, means branching type. If we are at one node at present time, then we can go either from left, right, or in many directions. This is just like a junction. Okay, so we have number of choices where to go, and graph consists of some nodes of their connected edges. Means how to represent the graph? Graph is represented by using nodes and number of edges connected, and the edges may be directed or undirected. Means there may be two types of graph: directed graph or undirected graph. Directed graph having the direction, means we can also say this is a one way, and undirected graph this is two way. If we are at node A and B connected with the edge, and we are presently at node A, then we can go in node B also, and if we are node B, then we can go into node A also in the undirected. But if we are directed edge from A to B, then we can only go from A to node B, and vice versa is not possible. And the graph is represented by using GV, means this is a set of vertex and set of edges, as we can see in the example. As this is a graph having the nodes, 5 nodes are there: node A, B, C, D and E, and this is a directed graph because this edges having, this is edge and edge having the directions, each edge has having the direction. So, this is a directed graph, and the following graph can be represented as we see set of vertex A, B, C, D, E and no edges. One is from A to B, so there is one set A to B. Another vertex B to D, so we have vertex B to D, DE, DEH, and we have also B to C. So, B as a source, C as a destination, so BC set here, and CA direction, not AC, this is CA direction, so we have CA set. So, as we know, just see, as we know, this is a non-linear structure. Means if we are at node B, so where to go? Either go node C or node D. So, how to decide where to go? Because this is a non-linear data structure, so the traversing techniques for the graph having different approaches. If we compare it with the just linked list is a linear data structure in which if we are present at a particular node, then we can go in a definite node. In the definite node only one choice is there, but here many choices are there to traverse the graph. So, the graph traversal. Now, the graph traversal, and this is also known as graph search, and this refer to the process of visiting or checking or updating each vertex in the graph. Means visit the each vertex at most one time. This is a graph traversal, and there are mainly two types of graph traversal techniques or algorithm. First is BFS, means breadth first search, and second is DFS, depth first search. As name suggests, BFS, in the BFS we visit the node at a same level, all the node visit first visit all the nodes present and at the same level and then go to next level. This is a BFS, but in the DFS we visit in depth first, means first visit a node, then go to the next level, then next level until exhausted, and then now some differences of BFS and DFS. BFS stand for breadth first search, this as we know, and DFS for depth first search, no problem. Now as per the data structure concern, to implementation of the BFS, which data structure is used? By using Q we can implement the BFS, we will see later, and to implement the DFS we will use the stack data structure. Stack data structure is used to implement the DFS. As we know, what is the order of stack? The order of stack is last in first out order, and the order of Q is first in first out order. So next, source. BFS is better when target is closer to the source, means if we are searching some data which is closer to a node, means source node, then BFS is more beneficial than DFS, because all the nodes are covered at the same level in BFS first, and DFS is better when target is far from the source. This is far from the source, then uh, if we use a DFS to implement or find the node which is far from the source node, then it is more beneficial to get data in better way. And suitability for decision tree, BFS consists never, so it is not suitable, this is not suitable for the decision tree, but DFS is suitable for the decision tree. And BFS is some speed concern, slower than DFS. And time complexity, both the time complexity, vertex and plus number of edges, time complexity for both are same. The time complexity of BFS is big O of V plus C, and this is big O of V plus C, visiting the node. Now we will consider the example here and traverse using. So traverse the given graph using DFS and BFS, and starting node is A node. So how to implement this? The given graph is this one, and we are we visit by using DFS and by using BFS, we traverse the graph. In the traversing of graph we need the adjacent node of each one. So first we write the adjacent node, so what is the adjacent node of A? Connected node from node A is direct connection from B and D. So the node is B and D. Adjacent node of A is node B and D. First write here. Now adjacent node of B, direct connection from B is A, F, C and G. So we write here A, then C in sorted order, then F and then G. Okay. Now what is the adjacent node of C? Direct connection from C is B, D, C, F and G. So we write B, D, F and G. Now the adjacent node of D, direct connection is A, then C, then E, then F. Okay. Now the adjacent node of E is direct connection D and F, and adjacent node of F, direct connection C, B, C and D, and the adjacent node of G is B and C, direct connection. Now we solve it, B and C by using DFS, starting from A. So first write here A. Now visit the node A first. So add it in the visited list, add node E. These are the list, not visited and visited. Now here remove the remove the visited node and add the adjacent of this particular visited node which are not present in not visited and visited list both. So at this time adjacent node of A is B and D, and B and D is not visited here, not is present in the not visited node list and not is present in the visited list. So add here B and D. Okay. Now from left to right visit the not visited node. So visit one node, that is B at this time. So add here A is already visited and now visit the B. So this is DFS. Okay. In the DFS we go in the depth first. So remove the B here and only left node is D, only left node is D. Now add the adjacent of visited node, that is B, which are not present in visited node, visited list and not visited list. So adjacent of B is A, C, F, G. A is already visited, C is not visited. So add C here in the front, add C here in the front. Okay. Now F is not present, add F, and next is G is not present also. So add G, and now D is also here, D is not visited already. So present D. Now CFG in place of B. These are the CFG are node adjacent to B which is not present in visited and not visited list. So add in the front of the not visited list. Okay. Now next visit the C. Now visit the C. AB is already visited. Now visit the C and remove the C from here and add the adjacent of C which is not present in this list and also in this list in the front of the not visited list. So now see the adjacent node of C, B is already visited. Now next adjacent of C is D is already waiting to visit. So do not add repeatedly. F is already waiting for visiting, and G is already waiting for visiting. So do not add any node here now. So remaining node is F, G and D now. So now visit the front node of this list, that is F. So visit the F, A, B, C, F. Now fourth node is visited. Now add the adjacent node of F which is not present in not visited and visited list. B is already visited. C is already visited. D is already waiting for visiting. So do not add any node further. So simply G and D. Now visit the node G. Node G in the front of not visited node. So visit the G, A, B, C, F and G. A, B, C, F and G is visited. Now adjacent node of G which is not present in the list, both list. B is already visited, C is already visited. So do not add any node. Now visit the G. G already visited, so only node is D. Now A, B, C, F, G. Okay. Now adjacent of G node, adjacent of now visit the D node. Now visit the D node here. Visit the D node and add the adjacent of D which is not present in the list. A already visited, C already visited, E not in visited, not present in not visited. So add E here. Add E here, and F is already visited. So now visit the E, now visit the E node, now visit the E node here. Now D and F adjacent of E node, D and F already visited. So now this is a empty, this is a empty list, no node to visit. So this is our complete, this is our complete data, means sequence A B C F G D E, A B C F G D and E. This is the our DFS pattern. Okay. Now by using BFS, same problem by using BFS. Again in the BFS we will use Q here, we will use Q here. Okay, we will use Q here, and in the DFS we will use stack. As just look here, stack. Which node visited first, which is in the front of not visited node, and we are adding if we are visiting F, and just look here, if we are visiting B, after visiting B we are adding the adjacent of node B in the front of this particular, means last in first out manner is preserved, last in first out manner is preserved in this. So we are using stack in the DFS form. Now see the BFS technique, simply start from the A, not visited A, now visit the node A, now visit the node A, adjacent the add the adjacent of node A, that is B and D, that is B and D. Okay. Now visit the B, visit the B, visit A is already visited, now visit the B. Now D is left, and add the adjacent of B which is not present in not visited and visited list. We have to add at the last of the not visited list, not in the front, in the last, in the rear part, in the last part. So D, so adjacent of B which is not present, adjacent of B, A is already visited, C is not here, so add C. F is not here in the not visited, so add F, and G is not here in any of the list, so add G. Now visit the front, that is D, visit the front, that is D, visit the D. Okay. Now CFG is here, CFG is here, CFG is here. Now add the adjacent of D which is not in the visited and not visited both. So D, A is already visited, C is waiting for visiting, and E not in the visited and not visited, E and F both, E and F both. So add here E and F, E and F, E and F here. Now visit the C, now visit the C which is in front of the not visited, visit the C, visit the C. Left node is FGE, FG and E. Now add the adjacent of C which is not in present in the visited and not visited. So here B is already visited, D is already visited, and F waiting for visiting, and G is waiting for visiting. So no new node to add here. Now visit the F node, visit the F, visit the F. Now remaining node are G and E to visit. Now adjacent of F which is not present, B, C, D, B, C, D, B, C and D already visited, so do not add any other node. Now G, visit the node G, only left node is E. Now adjacent of G, which is B and C, already visited, so do not add any node. Now visit the E, now visit the E node, now visit the E. Now adjacent of E, that is DF and DF. D is already visited, F is already visited, so this list is now empty. So stop the visiting further. Now this is our sequence by using BFS A, B, D, C, F, G and E. So this is the difference of DFS and BFS, how to visit by using DFS. In the DFS we use stack, in the BFS we are using queue. Why you using queue? Because this follows the sequence first in first out order. Just see here, A is visited first, then B comes, B is visited, then D is visited. So first in first out order. So BFS implement the queue. Now see here, so we have solved traverse the graph using DFS and BFS. Starting node is the same problem here. Now we can consider another example. Traverse the given graph using DFS, BFS, same type. We can also solve this. Now see here, just consider DFS here. DFS, simply this is not visited, not visited list, and this is visited list. Not visited and visited list. Now consider A is at the starting node here, that is A. Now visit the node A, add the adjacent node of A which are not present in visited, not visited. Adjacent of A is B, C and D, so add B, C and D here. Now add the first node, that is B, add visit the B node. Now C and D, now add the adjacent of B in the front of this list, this not visited list here, add the adjacent of here. Now adjacent of B is A, E and F. A is already visited, E, F, not here, so add E and F. Now visit the E, okay, F, C and D. Now add the adjacent of E is B only, and B is already visited, so do not need to add here anything. So A, B, E. Now visit the F. So remaining node are C, D. Now add the adjacent of F which are not present in the visited and not visited list. So adjacent of B and C, already B here and C here, so do not need to add. Now visit the C node. Visit the C node, visit the C node. Remaining node is now adjacent of C which are not present in this list. A, adjacent of C is A and F. A is already visited, C is already visited, so do not need. Now visit the D. Now A, B, E, F, C and D. Now visit the D. Here adjacent of D is only A which is already, so now this is empty. Now the sequence is this one. A, B, E, F, C and D. A, then B, then E. Just see, we are going to depth first. We are going in the depth, not at the same level first. We are going in the depth. Then F, then F, then E, then F, then C and D. This is the sequence by using DFS. Okay. If the same problem considered here by using BFS, same problem. If by using BFS, so again just see here, list is not visited and visited. Here not visited at the starting node. Same here, visit the A, add the descent of A, that is BCD, here BC and D. Now visit the B, add the, now where to add, this is BFS, so add at the last. In the case of DFS we added the node in the front, but in this case add the adjacent which is not present in both lists at the last position of the not visited list. So adjacent of B, that is A already visited, E and F. So add E and F here now. Now visit the C node and here D, E, F. As we can see, there are 6 nodes, 1, 2, 3, 4, 5, 6, and these 6 nodes already either present in the visited, not visited, or in the visited. So if we traverse and if we traverse a node and find the adjacent which are not present in not visited and visited list, so there are there will be no node to add newly, because already added A, B, C, D, E, F, A, B, C, D, F already here. So just visit the node A, B, C, then visit D. Now no new node, so E, F here. Now visit the E, A, B, C, D and E, only F node. Now A, B, C, D, E and F, no new node to add here, this is empty. So our solution using BFS is sequence A, B, C, D, E, F. Now see here, A, start from this, then go to B, then C, then D, same level. First cover all the nodes at the same level in the BFS, where then E and then F node. So our traversing at the same level, first our same level node, then go to next level and cover by using BFS, and this uses Q data structure and this uses stack data structure. So this is these BFS and DFS is used to traverse the, we can consider more example here, directed example and directed example, and so we can more elaborate these techniques. DFS, just if we say another example, there may be many more examples of DFS and BFS graph traversal technique. Just in the say our graph is a directed graph. If we consider a directed graph example, B, now C, now D, then E, okay, any connection may be here, F, G. So if we consider this graph, simply not visited A, we consider DFS, not visited A. Now the adjacent of visit the A, this is not visited, this is visited, visit the node A, add the adjacent of A. What is the adjacent of A? This is B, only B, not this C, because the direction of this is from C to A, not A to something. So A to B. Now add B, visit the node B. Now add the adjacent of B, which is only F. Here A, B. Okay. Now visit F. Adjacent of F is E. F is E. So visit the E. Okay. Oh, there is no way to go from E. Just see here. This is a node. This is direction. So E, the adjacent of E is D. Now visit D. A, B, F, E, D. Okay. Now see here. If graph is this, so A, B, F, E, D, and adjacent of D is A and C, but A is already visited. Now add the C here. Now visit the C, and after visiting C, all the nodes are present in the no C. Adjacent of C is A, D, and E. A, D, and E already visited, so this is empty now, and the our traversing using DFS is this one. So okay, thank you.